Hi there, today we're going to be talking about slope, kind of a continuation from yesterday when we were talking about a constant rate of change, which really leads into what a slope of a line is all about. So our definition here says the slope m of a line passing through points x1, y1 and x2, y2 is the ratio of the difference in the y coordinates to the corresponding difference in the x coordinates. As an equation, the slope is given by m for slope equals y2 minus y1 divided by x2 minus x1. So if you think before, we talked about a constant rate of change being equal to y over x. So what a slope is going to tell us is that if we take two values, a y2 minus a y1, and we divide it by the two x values, we should end up with our constant rate of change or our slope all being equal. Meaning that if I have a graph and I have 2 points, I should be able to take those two values here, whatever those points are going to be, and subtract them from one another, find the difference, and determine what the slope is going to be, or what that constant rate of change will be between the 2 points, if it's going to actually be a line. Now, make sure that x1 doesn't equal x2. If that's the case, then you end up with 0 on the bottom and it won't work. So you can't have x minus 2 minus x2 minus x1 be equal to 0, otherwise it just won't work. So here's a couple examples, looking at some points as well as looking at a graph here. It says find the slope of the line that passes through negative a, which is at -1, and b, which is at 2, 3. So essentially you're trying to figure out what is the slope between these 2 points. Now slope, we said before, is essentially y over an x value. Okay? And so when you look here, we can see, for example, depending on how you want to look at it here, that we're going up 1, 2, 3, 4. So our y value is an increase of 4, and our x value is going over 1, 2, 3. So while you can look at a graph sometimes and go, oh, my slope is 4 over 3, sometimes you're not given the graph. We can already see 4 over 3 becomes the solution over here, right? So we can look visually and say, oh, that's what I'm going to end up with. But you don't always have the graph to work with. And in today's homework, you're not going to have any graphs to work with. They're just going to give you points. And they want you to be able to use the points to determine what the slope is going to be. Okay? And this is important because you don't always have small numbers to work with either. So it's good to be able to figure out the slope using 2 points. So to do that, what we're going to do is make sure we have a y2 minus a y1, x2 minus x1, and we determine what those are going to be for the slope formula. So essentially, what we want to think about is what's our 2's and our 1's. So the first point they give you is often going to be our x value. So this becomes our x1 and our y1. This becomes our x2 and our y2 right there. So that's what our values are going to be. And now we're going to use those values and put them into the equation. So y2 is 3, so there's our 3, minus y1, which is -1, that's there. And on the bottom we have x2, which is 2, minus x1, which is -1. So 3 minus a minus, so when we subtract, that becomes adding, so that becomes a 4. And when we subtract a negative, it becomes adding the opposite, so it becomes a 3. So you end up with 4 over 3. And you can see the reason this can be complicated is if you forget how to add your integers, you can make a simple mistake in calculation. That's why we did that earlier in an earlier unit. So be careful there. So our slope becomes 4 over 3, and we can see visually, yep, that makes sense. So when going from left to right, the graph of the line slants upward. This is correct for a positive slope. Because it's a positive slope, we're going to be going up this direction. If it was a negative slope, then our graph would be going down that way with a negative slope, but we don't have that in this case here. The next one we do, let's take a look at it. So find the slope of the line that passes through C, which is 1, 4, and D, which is 3, -2. Again, if I want to visually just check it out real quick, I can see I'm going down 1, 2, 3, 4, 5, 6. So I'm going down 6. And then we're going over 1, 2. Alright, so when I reduce that or write that out, -6 divided by 3 is equal to, -6 divided by 2 is -3. So I should have a slope equal -3, which again, we can see we're going to get that there. But here again, I have a graph to look at and take a look. But if I don't have a graph, I need to use the formula. So you plug in the values, y2, which is -2, minus y1, which is 4, divided by x2 minus x1. -2 minus 4 equals a -6. 3 minus 1 equals 2. And you're down to where we were, -6 divided by 2, or -3. And again, because the slope is negative, that means that the line is going to be going down that direction. So when the slope is positive, we're going up, and the slope's negative, we're going down. It gives you a directional value there. Let's look at a couple together without the graphs to see how this works. Okay, so here we have our x1, our y1, our x2, and our y2. So we're going to do y2, which is 4, minus y1, which is 1, divided by x2, which is 3, minus x1, which is 0. 4 minus 1 is 3, 3 minus 0 is 3, and so our slope is simply 1. And that's okay. That means it's going to go up 1 over 1, up 1 over 1, up 1 over 1, like so. Okay? Next we have x1, y1, x2, y2. Again, labeling does help. You don't always have to label, but if you get stuck, it does help keep things straight. So we're going to do y2 minus y1, -2, divided by x2, 3, minus x1, which is 1. 2 minus a minus, we add the opposite, equals 4. 3 minus 1 is 2, so you have 4 over 2, or that reduces to simply 2 over 1, or 2. So our slope here is 2, or 2 over 1, meaning I'm going to go up 2 over 1, up 2 over 1, and I have a graph that looks something like that. Alright, number 3, we have x1, y1, x2, y2. We'll do 2 minus a minus 4 over 2 minus 4. Add the opposite, so 6 over 2 minus 4 is -2. And so we end up with 3 over 1, and it's going to stay negative. So you have -3 over 1, meaning this is going to go down 3 over 1, down 3 over 1, and we have a graph that looks something like that if we had to graph that out. Okay, so that's the idea. You're just using the values, plugging them in to y2 minus y1 over x2 minus x1, and solving that out. That'll be your assignment today, so go ahead and do the odd ones on the next page, and we'll see you back here to check them out in just a minute. Alright, here we go. Using our equation y2 minus y1 or x2 minus x1, let's find the slope for each of these points that are given to us. So, begin with 4 minus a minus 4 divided by 2 minus a minus 2. We're going to add the opposite, so that becomes 8. Add the opposite over 4, which reduces down to 4. 4 goes in there 2 times, sorry, and 1. So 4 goes in there 2 over 1, so our slope becomes 2 over 1, or simply 2, if we want to think of it like that. Our next one, we have -2 y2 minus y1 divided by x1, or x2, sorry, x2 minus x1. -2 minus 4 is -6. 4 minus 3 is 1. So I simply have -6 as my slope, or -6 over 1. It's going to be going downward because it's negative. Number 5. y2 minus y1 over x1 minus x2 minus x1. So 1 minus 6 is -5. -1 minus nothing is simply -1. Negative divided by negative is positive, so I have positive 5 as my slope, or 5 over 1. 7. y2 minus y1 divided by x2 minus x1. 5 minus 3 is adding the opposite. 2 minus 1 is 1. So my answer is 8. Next one we have a 0 minus 4 over 1 minus 0. So negative 4 over 1, or simply negative 4, a downward slope there. Number 11, we have 1 minus a minus 2 divided by negative 1 minus 2. So that becomes add the opposite. So we have 3. Negative 1 minus 2 is negative 3. So it becomes simply negative 1. 13. Negative 4 minus a minus 1 over negative 4 minus 2. Oops, I don't know why I put that there. Just minus 2. Minus 2. So that becomes add the opposite. And so negative 4 plus 1 is negative 3. Negative 4 minus 2 more is negative 6. So that becomes a positive 1 over 2. So we're going to go up 1 over 2 if we're doing a graph like so. 15. 0 minus minus 4 over negative 3 minus minus 1. So there's my y2 minus y1 over x2 minus x1. So it becomes add the opposite. So we have 4. Add the opposite. Negative 3 positive 1 is a negative 2. So we have 2 over 1, keeping a negative because positive out of negative is negative, so negative 2 over 1. Number 17, notice here that our x values are the same. Because the x values are the same, if I graph this, I have 1, 2, right? So here we go, 1, 2, whoops, 1, 2, 3. The first point is here at 2, negative 2. The second point is here at 2, negative 3. Oops, 2, negative 3. So there. So my line is actually going like this. So I'm just going straight up and down, meaning there is no slope that works. So we can't do this one because I can't have negative 3 minus a minus 2. If I do 2 minus 2, I get 0. I cannot divide by 0. So that's just not going to work there. Right? So it's not possible. There's no slope. Okay, it's just a straight line, it's a vertical line. There's not a slope. A slope has to go at like an angle like this, and that's not going to work. Number 19. We get 4 minus minus 3 over minus 3 minus 5. Add the opposite, so 7 over negative 3 minus 8, negative 8. So we have negative 7/8 there. A little bit different for that one. Next one we have 1 minus 25 over 1 minus 3. So we're going to end up with negative 24 over negative 2, which is going to reduce down to 12 over 1, or 12. And our last one, negative 2 minus a minus 2 over 3 minus 0. That becomes add the opposite. So we end up with 0 over 3, or simply a slope of 0. This one's just going to be a little weird because if I graph this one out here, okay, here's 0, negative 2, 3, negative 2, I end up with a line like this. So when your line is 0, you have a horizontal line there. If your slope is 0, it's going to go straight across, making a horizontal line. Okay, that's it for today. Hope you got that figured out and you're able to find a slope quickly and easily enough. We'll see you for the next lesson. Bye.